So in this video, we're going to solve radical equations. So when we're trying to solve the equation, we're trying to isolate the variable. So to isolate the x in this example 1, at some point we're going to have to square both sides of the equal sign to remove the radical sign. Okay? And there's a property up here that says if a is equal to b, well then if we square a, that should be equal to the square of b. Okay, so when you look at example 1, the left side of the equal sign can be considered a, the right side can be considered b, right? And again, by this property, if we know a is equal to b, then the squares would be equal, right? So the steps to solving this equation in example 1, isolate the radical on one side of the equation, right? So we want to get the square root by itself, or the radical sign by itself. So the first step is to remove this 2 by dividing both sides of the equation by 2. Right? That leaves us with just the radical on the left side equal to 6. So how do I access what's underneath the radical sign? Well, I'm going to need to square both sides. Okay, so if we square both sides, remember, anytime you have a radical sign, the square of it is simply what's left underneath the radical sign. Right? So if I had the square root of 8, if I were to square this, I'd be left with just 8, right? So when you square the radical sign, you're left with what's under the radical sign. So for example, if I had the square root of x squared, the answer to that would be x. So when we square the x plus 1, the square root of it, you're going to be left with simply x plus 1. Right? And on the right side, the square of 6 is 36. We bring the 1 over, and you're left with x equals 35. Okay. Now, it is important to check your solution. Okay, so we take the x equals 35 and put it back into the original equation. Okay, and at the end, when you do the calculation, you end up with 12 equals 12, so it checks. It is very important to do the check, because sometimes it actually doesn't work out, and we have what's called an extraneous solution. All right, so let's take a look at problem 1. So problem 1, it says isolate, all right, we're going to solve 1 plus the square root of 4x equals 9. So the first step is to isolate the radical on one side. So if we subtract 1 from both sides, you end up with the square root of 4x equals 8, right? Right, we were able to remove the 1 by subtracting 1 from both sides. Next, we square both sides. Okay, so if I square 4x and I can square the 8, that would leave me with 4x equals 64. And then step 3 says solve. So if I divide everything by 4, right? So I have 4x equals 64. If we divide both sides by 4, we're going to be left with x equals 16, right? So before I write my answer, x equals 16, I have to check it, right? So I want to place the 16 back into my original equation. So the original equation was 1 plus the square root of 4x. So if we're saying x is 16, we can write that equals 9. All right, so this gives us 1 plus the square root of 64 equals 9, and then you end up with 1 plus 8 equals 9, which is correct, right? We know that 1 plus 8 is indeed equal to 9. So the solution is x equals 16. Okay, let's take a look at the next one, example 2. Okay, so in example 2, we're given solve the square root of x equals -3. Okay, so it says recall that the square root of x is never a negative number. So really, there's no value of x that will result in a -3. So the answer is no solution. Okay, and when we actually do the steps, when we try to solve this, right, we square both sides. You end up with x equals 9, right? It looks like it works. But the problem, when we place this 9 back into the equation, it doesn't work, right? Because the square root of 9 does not equal -3, right? So when we do the steps algebraically, it looks like we get an answer, x equals 9, but the check does not work. That's why it's important to do the check, right? So when we have a situation where the check does not work, we have what's called an extraneous solution, okay? So it's important to always do the check, okay? Let's take a look at example 3. So for example 3, all right, so it looks like we have 2 radical signs here. Oh, let's see here, right? We have one here and another one here. So what we can do is we can add or subtract the square root of x from both sides to end up with something that looks like this, right? So I'm simply going to bring the negative, here it is, the negative square root of 3x minus 10. So if I add that to both sides, this is what I would end up with, right? So now if we square both sides, right? So if we take the square root of x, right? So we have the square root of x. I'm going to square that, and we have the square root of 3x minus 10. We square that. That's going to leave you with x equals 3x minus 10. Right? When we square the radical sign, we're just going to be left with whatever under the radical sign. All right, so it says solve the resulting equation. So if we subtract 3x from both sides, you're going to end up with -2x equals -10. And if you divide both sides by -2, you end up with x equals 5. All right, so it's important to do the check to make sure that this actually does check out. Okay, so I'm going to replace 5 here and here. Right, so I have the square root of 5 equals the square root of 3 times 5 minus 10. And it looks like this is going to work out, right? So we have the square root of 5 equals the square root of 15 minus 10, which leaves you with the square root of 5 equals the square root of 5. Right? So the answer is x equals 5 is our final, whoops, I hit the wrong button there. My stylus is going a little crazy here. Okay, there we go. So final solution is x equals 5. Okay, so we'll stop here and we'll finish up this activity with one more video.